polynomials. Yesterday we looked at the fundamental theorem of algebra, okay, that let us take the solutions and build the polynomial from that, and we also looked at factoring. If we knew one of the zeros, we had to do some synthetic division with some kind of tricky square roots and i's. But we'll talk a little bit about some strategies for that later on today. But let's look at solving polynomials. So the number one requirement, now you don't run into this as much with polynomials as you do with quadratics, but just like with quadratics, before you start solving, it's got to be equal to 0, okay? It has to be equal to 0. You can't do this if it's not equal to 0, okay? That's the key. So our first strategy, just like with solving quadratics, is to factor, okay? Is to factor. Oh, this is not, this is on another worksheet. Hang on. Hang on, sorry. Here it is. Aha. Sorry, here are the problems we're going to be working on. Okay, so while I'm passing these out, looking at number one, what's the first thing we need to do to factor number one? Take out an x. Okay, just like always, the first thing we look for is a GCF. Okay, it's got to be equal to 0. Then we look for GCF. Okay, and then we can look to see if we can factor further. Okay, we got to look to see if we can factor further after that point. All right, so if we take out an x here, we are left with x squared plus 5x plus 6. So then that quadratic trinomial, okay, second degree, 3 terms, factors into x plus 3 times x plus 2. 3 times 2 is 6. Ouch. 3 plus 2 is 5. Okay? So then once it's factored, we take all of its factors and we set them equal to 0 to solve. X equals 0, x plus 3 equals 0, and x plus 2 equals 0. The first one is solved already. X equals 0. That's our first solution. The second one, we subtract 3 from both sides, so we get -3 for a solution. And for the third one, we subtract 2 from both sides. So it's a cubic function polynomial to begin with. Third degree, we're expecting 3 solutions. We got 3 real solutions here. You can always check them, plug them back in after you get them there at the end. Make sure it equals 0. All right, number 2. Can we factor that? Yeah, we should. Okay. There's no GCF because they don't all have an x. But we did some like this when we were factoring quadratics. This is the quadratic form. Remember, x squared times x squared is x to the 4th. And let's see here, -7 and +5 add to give us -2. And the x squared takes care of itself because when we multiply the outside, we get plus 5x squared. When we multiply the inside, we get -7x squared. Those combine to give us the -2x squared. Now, it would be great if these were then the difference perfect squares, but they're not. The first one, 7, is not a perfect square. The second one, it's not the difference, okay? So we need to use our method to solve by taking square roots, okay? We still set these equal to 0. And when we solve these, the first one we add 7, so we've got x squared is equal to 7. Then we take the square root to get rid of the squared, and we've got x equals plus or minus square root of 7. When you take the square root, do not forget the plus or minus. You gotta have the plus or minus with that. All right, with the second one, when we subtract 5 from both sides, we get x squared equals -5. When we take the square root, what do we have to remember in addition to the plus or minus? Take out the I because we're taking the square root of a negative number, so that comes out as I in front of the square root. So it was fourth degree, a quartic trinomial, fourth degree, 3 terms. So we expect 4 solutions. It looks like 2, but really we have 4 because we've got positive and negative square root of 7, positive and negative I square root of 5. You can check these too, okay? You may feel a little less confident about these since they look kind of weird. Type them in, okay? Remember, let me remind you how to store values. If we're checking I square root of 5, the store button's beside the number 1. Store it as x, and then type in the original polynomial, x to the 4th minus 2x squared minus 35. What are we looking for? 0, and we got 0, so we're good. Okay? If that one worked, chances are the other ones are going to work, but you know, you might want to check the square root of 7. You never know, you might have messed up on that part. And to save yourself some time, press second enter. That brings up the last thing you typed in. Press second enter again. It brings up the previous thing. And that one also gives us 0. Okay, let's look at number 3. What does number 3 look like? Grouping. Lovely. Y'all are making me so proud with this factoring thing. Okay, so with the first pair, we take out x squared. And we've got x plus 1 left. What do we take out of the second pair? Negative 5. Good. You got to remember that negative. And when we take out the negative 5, it leaves us with x plus 1 as well. Okay, notice that that sign does change. This has got to be the exact same linear factor. If it's not, then factoring by grouping didn't work. So we've got x plus 1 times x squared minus 5. Okay, x squared minus 5 is close to being the difference of perfect squares, but 5 is not a perfect square. So then we just set each of these equal to 0, and we solve them for x. So the first one, we subtract 1 from both sides. We get negative 1, x equals negative 1. The second one, we add 5, so we get x squared equals 5. Square root it, x equals plus or minus square root of 5. Okay. This polynomial was a cubic. You name it by the degree first, and then the number of terms. So this is a cubic 4-term polynomial. We don't have a fancy name for 4 terms. We just call it 4 terms. Okay. So cubic, 3rd degree, 3 answers. We've got a real, rational. Okay, rational means it's a whole number of fractions, a negative 1, and then this is 2 irrational. Square roots are considered irrational numbers, 2 irrational solutions. Okay, let's look at number 4, x cubed minus 125. What kind of factoring do we have there? Perfect cubes. Okay, so remember how that worked. We take the cube root of both terms, bless you. So the cube root of x cubed is x. The cube root of 125 is 5. All right, then we build the trinomial from that. We square the x, we multiply the x and the 5 together, and we square the 5. Then we use what? SOAP. Same sign that we started with. We started with a negative. Opposite, in this case, is a positive, and the last sign is always positive. Bless you. Everybody's sneezing this morning. I was too. While I was eating my breakfast. That's the worst. That is the worst when you're eating. Anyways, sorry, y'all probably didn't want to know that, but I shared anyways. All right, so we set x minus 5 equal to 0. Remember, I told you that quadratic, when we factor perfect cubes, that quadratic doesn't factor. So what's our choice for solving if it doesn't factor? If something doesn't factor and we got to solve it, what can we do? Quadratic formula, okay? Or completing the square, but I really don't want to complete the square on this one because I'd have to divide 5 by 2, which doesn't divide evenly, and I did them with a fraction. I just don't want to go there. I'd rather use the quadratic formula. So let's go ahead and find the easy solution first. X equals 5. That's the easy part, right? Okay. Now, quadratic formula. Our A is 1, our B is 5, and our C is 25. So x equals the opposite of b, so -5 plus or minus the square root of b squared. I'm going to go ahead and square it. So 5 squared is 25. Minus 4 times a times c, all over 2 times a. So let's simplify things. We've got 25 minus 100, so that's the square root of -75. Okay, let's simplify our square root here. First of all, it has an I, so we take that out. 75 is 25 times 3. The square root of 25 is 5, so that comes out in front of the I. The 3 is not a perfect square, so we leave it under the square root. Okay? I'm trying to be careful not to say that you can take the square root of 3. The square root of 3 exists. It's just not a nice, pretty whole number. Okay? So I don't want to say that you can't take the square root of 3. It's not a perfect square. So it stays. And that's over 2. And that's all the simplifying that we can do. Okay? It would be great if we had 5 or a multiple of 5 in the denominator, since we've got the -5 plus or minus 5 there. But all 3 of those numbers would have to simplify to be able to simplify those coefficients there. Okay? I would definitely want to check that answer. Just be careful. This is why I want to point this one out. You kind of got to do it in pieces, or you have to be careful with your parentheses. So type in the numerator first, -5 plus 5i square root of 3. Press enter, then divide by 2. Don't try and do it all at one time. Type in the numerator, then divide by the denominator, store it as x, and then check it. X cubed minus 125, looking for 0, we got 0. Okay? So there are our 3 solutions to this cubic binomial. 2 terms, 3rd degree, 3 solutions. Okay, this one has 2 within it, plus or minus. Okay, let's do one more together, and then I'll let y'all practice for a little bit. We've got x cubed plus 10x squared plus 25x is equal to 0. So what do we do first? Take out an x. Take out a GCF of x. So we've got x squared plus 10x plus 25. That trinomial that we've got left there has a special name. Anybody remember what it is? Perfect square trinomial. Because 5 squared is 25 and 2 times 5 is 10, so this factors into x plus 5 times x plus 5. Now, typically, we go over here and we write that as x plus 5 squared. If we were just factoring, then we would write that as x plus 5 squared. But we're solving here, so we're going to leave it the way it is right now. So we set each of our factors equal to 0. So x equals 0, x plus 5 equals 0, x plus 5 equals 0. So there's one solution. Subtract 5 from both of these, so we get the same answer. So this is what we call the multiplicity. Okay, so if you see this on the answer key, you'd see 0, -5, multiplicity 2, because it was repeated twice. Okay. If somehow we had factored this and we had x plus 5 cubed, that would be -5 with multiplicity of 3. Okay? So it's just however many times that factor shows up, that's its multiplicity. Okay. Any questions about solving? First reaction, factor. Okay? After you factor, you may have to either solve by square roots or solve by the quadratic formula, but factoring should always be your first instinct, okay? If it's not factorable, you're going to have to graph it and find the zeros, okay? If it is not factorable for some reason, you're going to have to graph it and find the zeros, okay? But otherwise, you're going to try and factor.